If A, B, C are integers not all equal, this sign is cube root of unity. Unity is not equal to 1, then all minimum values of A plus B infinity plus C infinity square is. So let's say A plus B minus 1 plus I root 3 upon 2 plus C minus 1 minus I root 3 upon 2. How we got this equation? A plus B infinity plus C infinity. You have to find for this. So we will replace the values. After that, this is nothing but 2A minus B minus C upon 2 plus B root 3 minus C root 3 upon 2. Common is I. So square root of 2A minus B minus C the whole square upon 4 plus root 3 upon 2 B minus C the whole of the square. Therefore half root of 2A minus B minus C the whole square plus 3B minus C the whole square. Solving the equation, you get half root of A square plus B square plus C square minus AB minus BC minus CA. And this simplified form choose A minus B the whole square plus B minus C the whole square plus C minus A the whole square. That is, now since A, B and C are not all equal, we can't say A is equal to B is equal to C. So taking minimum difference can be 1. So let's say if A is equal to B, then B minus C will be 1 and definitely C minus A will be 1. So the value is will be half of 1 plus 1. We are replacing the values. So that is half into 2, that is equal to root of 1 is 1. So answer is B. If argument Z is less than 0, then argument Z conjugate minus argument Z is equal to, the answer to it is A. How will you get A? So let argument for Z be equal to minus theta. Then argument for minus Z is equal to pi minus theta. So here argument of minus Z is equal to minus argument of Z, that is equal to pi minus theta minus theta, that is equal to pi. So the answer is pi. If Z1, Z2, Z3 are complex numbers such that modulus Z1, modulus Z2, modulus Z3 is equal to 1 upon Z1 plus Z2 plus Z3 is equal to 1, then Z1 plus Z2 plus Z3 is equal to A. How will you get the answer? Z1 square is equal to Z2 square is equal to Z3 square is equal to 0. So Z1 modulus Z1 is equal to modulus Z2 conjugate Z2 equal to Z3. Z3 is equal to 1. So Z1 is equal to 1 upon Z1. Z2 is equal to 1 upon Z2. Z3 is equal to 1 upon Z3. So what you get is Z1 plus Z2 plus Z3 is equal to 1 upon Z1 plus 1 upon Z2 plus 1 upon Z3. This all. So both are similar. Z1 plus Z2 plus Z3 is equal to Z1 plus Z2 plus Z3. So this is equal to 1. If this is the cube root of unity of equation z cube is equal to 1, then the value 1 upon 2 plus 3 upon 8 plus 9 upon 32 plus 27 8 till infinity, such that this is the infinity upon 2 plus infinity square is equal to 1. So here given expression we know that 2 times of it when you all do half upon 1 minus 3 upon 4, that is half upon 1 upon 4, that is equal to 2. So 2 times of infinity plus half plus square plus, that is equal to infinity plus infinity square is equal to 1. So the answer is equal to minus 1. If 2 cos theta is equal to x plus 1 upon x and 2 cos is equal to y plus 1 upon y, then values of cos theta plus will be, here you will solve the equation. Let's say x is equal to cos theta plus I sin theta and y is equal to cos of the sine plus I sin. Now xy will be cos theta plus I sin theta multiplied by this cos theta plus I sin. So 1 upon xy is equal to cos of theta plus z minus I sin. Adding x y plus 1 upon xy, you get as 2 cos of theta plus the sine, that is nothing but half of xy plus 1 upon xy. So your answer is C. The complex numbers z1, z2, z3 satisfying z1 minus z3 upon z2 minus z3 is equal to 1 minus I root 3 upon 2 are vertices of triangle. Okay, so here half minus I root 3 upon 2, this is your in the form of a plus bi. What you get, a square plus b square is half plus 3 upon 4, that is root 1 is equal to 1. z1 minus z3 is equal to z2 minus z3. So z1 minus z2 upon z2 minus z3 minus 1 is equal to 1 minus I root 3 upon 2 is equal to minus 1. So z1 minus z2 upon z2 minus z3 is equal to minus 1 minus I root 3 upon 2 So 1 upon 2 minus root 3i upon 2, that is 1 upon 4 plus 3 upon 2, that is equal to 1. So in this you find this is also equal to 1. So even this was 1, this was 1. So from 1 and 2, Z1 minus Z3 is equal to Z2 minus Z4 is equal to Z1 minus Z2. Now here the vertices is equal to 1. It's an equilateral triangle. If 6i minus 3i 1, 4 3i minus 1, 23i is equal to x plus yi, then you have to find x and y values. So determinants, coming to determinants, you get here as minus 3i, 6i, 4, 20, 1, 1, minus 1, I, minus 1, I equal to 0. So this is in the form of, you have to follow the equations and you have to get it in the form of x plus yi. So here you will find x plus yi is equal to 0. So x is also equal to 0 and y is also equal to 0. This infinity is an imaginary unit, cube root of then you have to find the value 1 plus infinity square raised to 7. How do you find it? Now this is equal to minus infinity square raised to 7, that is minus 2 times of raised to 7. So minus 2 raised to 7 into infinity square raised to 7, that is minus 128, 1 into 4 square minus 128 square. So your answer is C. Sorry, answer is D. If infinity, this is not equal to minus 1, okay, and is a cube root of unity, then all your factors 1, 1 minus I, 1 plus infinity square minus 1 plus infinity square minus 1 equals, now here you have to use determinant properties. Determinant properties, one of them is 1 minus I and minus I. Here you are taking minus 1 plus infinity minus 1. So 1 minus I minus 1 plus infinity square minus 1. We know that infinity square plus infinity is equal to 1. Now here two rows are identical, R1 and R2, and as per the properties of determinant, this is equal to 0. The answer is A. Z and infinity are two non-zero complex such that modulus of Z and modulus of infinity and Z plus argument of this argument is equal to Ti, then Z is equal to what? Okay. So this, let Z, W and R now all be equal to R, and argument of W is equal to theta. So W is equal to R of cos theta plus I sin theta. So argument of Z is equal to pi minus theta. So Z is equal to R of cos of pi minus theta plus I sin pi minus theta. So this is r minus cos theta plus I sin theta. That is nothing but r of cos theta minus I sin theta minus common. So that is minus z. The answer is B. For all complex numbers z1, z2, z1 is equal to 12 and z2 is 3 minus 3 minus 4 are equal to 5. Minimum value of z1 minus z2 is equal to. So here z1 and z2 is given. So first of all we need to find z1 minus z2. So z1 minus z2 is equal to z1 is a circle having a center of 12, let's see, and here so z1 is equal to 12 where your center for a circle is 0 0, right? After that z2 minus 3 minus 4i is equal to 5. Your center is 3 comma 4 and your radius is 5. So minimizing, you get z1 minus z2 as BC, let's say OC minus OB. You need to plot these details on the diagram. This is your y-axis. This is your x-axis. You plot a circle. This is your OC. This is your A and this will be your B. So your B is 0 plus 12y and your this is minus 12 plus 0y. Here you plot a circle. Okay. You get one point here. So OC minus this OB. Now this whole was 12. Your OB, this is 10. So your answer is 2. If 1 plus I upon 1 minus I raised to x is equal to 1, then you have to find the following. So 1 plus I into 1 minus I upon 1 minus I the whole square raised to x is equal to 1. 1 plus 2i plus 2i square upon upon 1 plus I square. So what you get here is 1 plus I, 1 plus I upon 2, right? After that I raised to x will be equal to 1 irrespective of the power. So x is equal to 4n when any of your n is a positive integer. So the answer is D. If z and y, w are two z and w, if z and w are two non-zero complex numbers, and zw is equal to 1, and argument of z minus argument of infinity is equal to pi upon 2, then modulus of z is equal to a, b, c and d. Have to start with this. Here our first step will be, so here let w and this infinity be equal to 1. So argument of z minus argument of w be equal to pi upon 2. So z upon w is equal to z upon wi is equal to z square. So z I. So your answer is I. Your answer is 1 upon I. Let z1 and z2 be two roots, z square plus az plus b is equal to 0, and z being the complex numbers. Assume that the origin z1 and z2 form an equilateral triangle. Then a square is equal to b, or a square is equal to 3ab. C, a square is equal to 4ab. And the fourth one, a square is equal to b. Here, let's start first with that roots are for z square plus az plus b is equal to 0. And if the roots are z1 and z2, z1 plus z2 is equal to minus a, and z1 z2 is equal to b. Now since it is an 0 z1 and z2 form equilateral triangle, 0 square plus z1 square plus z2 square is equal to 0 z1 plus z1 z2 plus z2 0. So z square 1 z2 square is equal to z1 z2. So z1 plus z2 the whole square is equal to 3 z1 z2 is equal to a square is equal to 3ab. So this is your a, 3a, b. What values you have assumed? If z is equal to 1 and w is equal to z minus 1, where z is not equal to minus 1, you have to find the real part of z. Okay. So z minus 1 upon z plus 1 into z plus 1 upon z plus 1. This whole will be equal to 0. So what you get is z square minus 1 upon z plus 1 the whole square is equal to 0. Now we know that modulus of z is equal to 1 and z square is also equal to 1, and 1 minus 1 is 0. 0 upon anything will be 0. Let zw be the complex number such that z plus iw and the argument of zw is equal to pi, then the argument for z is equal to what? So first z plus iw belongs here z minus IW is equal to 0. Z is equal to IW. Argument of ZW is equal to pi is equal to argument of Z plus argument for W is equal to pi. So argument for Z plus argument of Z upon I. Instead of W, I am writing Z upon I is equal to pi. So argument for Z plus argument of Z minus argument of I is equal to pi. I have split both of them. If it's in division, it gets split to subtraction. So 2 argument of Z, this is equal to pi upon 2 equal to pi. So 2 argument of Z is equal to 3 pi by 2. So argument of Z is equal to 3 pi by 4. If Z is equal to x minus iy, Z raised to 1 upon 3 is equal to p plus I cube, then x upon p plus y upon q slash p square plus q square is equal to what? So, cubing, so Z 1 upon 3 is equal to p plus I cube. To remove this cube, I am taking cubes on both the sides. What you get is Z is equal to p cube plus I cube. Now that is nothing but a cube plus b cube. So p cube minus 3a square b. So 3a square b plus 3ab square plus minus I cube q cube. So p cube minus I cube plus 3ip square cube plus 3p square cube minus q cube I is common for both. So x minus yi is equal to p square minus 3q square plus q square minus 3p square. Here this is for I. So x is equal to p minus 3q square upon p, and y upon q is equal to q square minus 3p square. So next step will be adding both of them, x upon p plus y upon q, because that's what you have to find. 2 upon p square plus q square. When this 2 goes down, the value is equal to 2. If modulus of z square minus 1 is equal to modulus z the whole square plus 1, then z lies on which axis? It will lie on the, so here it is minus 2, your answer is minus 2, so your option is D. The next one, if z square minus 1 is equal to modulus z square plus 1, so z is equal to, we know that, x plus yi, right? Now z square minus 1 is equal to modulus z square plus 1. So this is nothing but x square plus y square minus 1 is equal to x square plus y square plus 1. So x square plus y square minus 1 is equal to x square plus y square plus 1, or x square plus y square minus 1 plus x square plus y square plus 1. Now here 2 is not equal to 0, or 2x square plus 2y square is equal to 0. X square plus y square is equal to 0. So which is a point on a circle? Which is a point on a circle? Which is a point on a circle, as both the coordinates, the square will be 0. If the infinity be a cube root of unity and 1 plus this infinity square plus raised to n plus, then the least positive value of n is, so 1 plus raised to n is equal to 1 plus infinity raised to 4n. So here this is nothing but 1 raised to 4 n, and here I am writing 1 plus infinity 2 raised to n. So this is nothing but minus infinity raised to n equal to minus infinity square raised to n. So this infinity n is equal to 1. Here n is equal to 3. If z1 and z2 are two non-complex numbers and z1 plus z2, argument of z1 minus argument of z2 is equal to, let z1 is equal to r1 e raised to I theta 1 and z2 be r2 e raised to I theta 2. Therefore z1 plus z2 will give you square root of r1 cos theta 1 plus I sin theta 1 plus r2 cos theta 2 plus I sin theta 2. Hence r1 is equal to r1 square plus r2 square plus 2r1 r2 cos theta 1 minus theta 2. Therefore r1 plus r2 plus 2r1 r2. Here theta 1 minus theta 2 is equal to 0. So cos 0 is 1. So r1 plus r2, if theta 1 is equal to theta 2, that is equal to z1 plus z2 if argument for z1 is equal to argument for z2. So z1 plus z2 is also equal to 0. So your option is D. If the cube root of unity are 1, then the roots are of the equation x minus 1 cube plus 8 are equal to 0. Solving the equation, so x minus 1 cube plus 8 is equal to 0. That is x minus 1 the whole cube is equal to minus 8. That is x minus 1 the whole cube is equal to minus cube. Therefore x minus 1 is equal to minus 2, and hence that is minus 2 minus 2 infinity square. Hence x is equal to -1, 1 minus 2 infinity, and 1 minus 2 infinity square. So your option will be D. If z is equal to, if w is equal to z upon z minus 1 upon 3i and w is equal to 1, then z lies on. So let's say z is equal to, w is equal to z minus 1 upon 3i. So w, modulus of w will be z upon z minus 1 upon 3i. Therefore z is equal to w z minus 1 upon 3i. Hence z is equal to z minus 1 upon 3i. Now since w, modulus of w is equal to 1, the locus of z is the perpendicular bisector of line joining 0 plus 0i and 0 plus 3i. So it is basically a straight line. Answer is B. The locus of z which lies in the shaded excluding the boundaries is best represented by here, starting with, here you will see AB will be equal to AD will be equal to AC. Here AB is equal to AD and this point is C. Okay, and this point is 1, 0. So it's also equal to AC. All the points are same. Now BCD is an arc having center as in radius is, let's say, 2. So the shaded part or shaded portion is outer exterior of sector A, B, C, D, A, that is A, B, C, D, A. So this part, exterior part, here it will be greater than 2. So Z minus pi by 4, the value is given, will be less than argument of Z plus 1 which will be greater than pi by 4. So when I combine both of sectors, we will see that argument of Z plus 1 is less than pi by 4. So combining 1 and 2, this is our correct answer. If z is equal to -1, then the principal value for argument of z raised to -3 will be equal to b, 2 pi by 3 or 2 pi. The complex number of sin x plus I cos 2x and cos x minus I sin 2x, and the conjugates will be D. no value of x since, because when you take the conjugate the signs will change, right? And if signs will change for each other, the answer will be nil for x. For any complex number z, the minimum value modulus of z plus modulus of z minus 1 is equal to 1. If z1 is equal to 8 plus 4i and z2 is equal to 6 plus 4i, and the argument z minus z1 upon z minus z2 is equal to pi by 4, then the argument, so we will substitute the value z minus 8 plus 4i, the conjugate, then pi by 4 is, then z is equal to, yeah. So you will substitute the value z minus 8 minus 4i upon z minus 6 minus 4i is equal to pi by 4. I will substitute the values, I will simplify the equation, and the answer will be B, that is modulus of z minus 7 minus 5i is equal to root 2. You can z minus 8 minus 4i upon z minus 6 minus 4i is equal to pi by 4. So z minus 8 minus 4i upon 4z minus 6 minus 4i is equal to pi by 4. Here you simplify, you get in the modulus as z minus 7 minus 5i equal to root 2. If root 3 plus I is equal to a plus bi c plus di, then tan inverse of b upon a plus tan inverse of d upon c will be equal to pi by 6 times of n pi for the same integer n. Because here you will solve this equation a plus bi, taking real part together, imaginary part together, you get your a and b, and similarly you get your d and c. Here you are using the amplitude, you are using the values what you get for a and b. So your answer will be pi by 6 plus n pi plus for some integer n. The value of x and y which satisfies the equation 1 plus x into x minus 2i plus 2 minus 3i y plus I upon 3 plus I, 3 minus I is equal to I. Here I will cross multiply the equations taking LCM. You have to distinguish the real part and the imaginary part. So your x is your, let's say, the real part, and y is your imaginary part. So when you solve this equation, when you cross multiply, you will get the answer as, that is C. I'll show you. 1 plus I, 3 minus I, x plus minus 6i plus 2i square plus 2 minus 3i, 3 plus I, y plus 3i plus I square is equal to 9 minus I square into I. So I will take it opposite side. 3 minus I, 3 plus I, minus I square x, minus 6i, minus 2 plus 6 plus 2i, minus 9i, minus 3i square, y plus 3i, minus 1 is equal to 10i. So what you get is 4 plus 2ix plus 9 minus 7i y is equal to 13i plus 3. As I said, distinguishing the real part and imaginary part. So 4 plus 2i, 4, you will open the bracket, 4 plus 9y plus 2x minus 7y, I common, equal to 13i plus 3. Now 4x plus 9y is equal to 3 and 2x minus 7y is equal to 13. Solving the equations simultaneously, you get x is equal to 3, y is equal to minus 1. If a plus bi, c plus di, e plus if, g plus ih is equal to a plus bi, then a square plus b square, c square plus d square, e square plus f square, and g square plus f square will be equal to a square plus b square. How? So here you will start with your equation a plus bi, c plus di, e plus fi. The sol is equal to a plus bi. After that, in case I take the conjugate a minus bi, c minus di, e minus fi, and g minus hi, I will get a minus bi. When I multiply both these equations, I will get a square minus b square. When I multiply each and every factor, it will get cancelled, and what you get is a square plus b square. So the answer is a square plus b square.